Hello, we're going to talk briefly about systems of equation and solving them by graphing. So we've got a basic story, and I've just sketched the outline of it. It was $600 to get a room ready to rent. $15 per night for the food and utilities is an additional cost, and you earn $75 per night in revenue. So the equation, the cost, is 15 times x plus 600. X is the number of nights. The 600 is a fixed cost. That's how much it costs to get the room ready. $15 is a repeating cost. The word per tells you that it's going to occur more often. Per night is times night. 600 is in dollars. 15 is dollars per night. X is nights. Dollars per night times night gives you dollars. So dollars plus dollars, and the cost is in dollars. You earn, this is our revenue, $75 per night. Again, it's multiplied. So revenue is in dollars. $75 per night times night changes that back to money. So we've got the two equations, and we want to know when these two lines intersect. When will my expenses, my costs, be the same as my revenue? Well, if I've rented the room for 0 nights, I've already spent $600. When I rent the room for 1 night, so this is the equation, the cost equals 15x times plus 600. So 15 times 1 plus 600 is 615. It would move to 630, $645, $660. 15 times 5 is 75 plus 600, so $675. $690. And I can just continue adding, excuse me, 15 every time because that is also the slope. So in 7 nights, you have spent $705. 8 nights, it's $720. 9 nights is $735. 10 nights would be 10 times 15, 150, plus 600, 750. And then I'm going to have to squeeze this in at 675. Let's write it underneath. 765 for 11 nights. Let's come to our revenue. That's the money we're earning. That's 75 times X. There is no revenue generated before you start spending money. So no revenue on 0 nights. $75. 150, and you can see you've earned far less than you have spent. So 225, 600, you're getting closer. That's not 600, that's completely wrong. That would be 300, 375, 450, 525, 600, so there's the 600 I was looking for. Okay, but we're still not quite there, so 600, we're now at 675. Then on night 10, it would be 750, and on night 11, it would be 825. So right here, we can see on night 10, and mine's sort of squished down in there, and I apologize for that. At night 10, the cost and revenue both total $750. Break-even point for business, and in this case, for the two lines meet. So they intersect at an X of 10 and a Y of 750. 10 nights, and I forgot to put at night 10 nights, $750. Okay, so looking down here at some points, we've got the point 25. Will these two lines intersect at point 25? I'm going to substitute. X is 2, y is 5, so 2 plus 5 equals 7. Well, this is a good point. I'm going to put it OK here. And then 2 times 2 plus 3 times 5, does that really equal negative 11? Well, 4 plus 15. So we've got 19 does not equal negative 11. So this is not a point of intersection. Let's try this one. We've got x is negative 2, y is 0. Does 0 equal negative 2 times negative 2 minus 4? Well, this would be 4 minus 4. And this is true. And does 0 equal negative 2 plus 4? 0 does not equal 2, so not a point of intersection. So we've seen 2 that are not. Let's try this point. Okay, so x plus y equals 6, and the point is 5, 1. So does 5 plus 1 equal 6? Well, we can see that one without a whole lot of work. And 2 times 5 minus 1, 2 times x minus 1 equals 9. 10 minus 1 equals 9. So 5, 1 is a point of intersection. Let's try spelling intersection correctly. Okay, so to graph these, I'm going to grab a sheet of graph paper, which I have now misplaced. There we go. So I've got the point negative 2 times x, so y equals negative 2 times x plus 5, and y equals 4x minus 1. So I'm going to set up a grid. A little bit of the bulk out of here. So I've got a point. I'm just going to sketch in a graph. I'm going to put in an xy coordinate. So here's my x. This is my y coordinate. And I'm going to graph these using point slope. So I'm going to come up 5. 1, 2, 3, 4, 5 for the intercept. And the slope is negative 2, 1. So I'm going to drop 2, go over 1, drop 2, go over 1. And it's definitely a pretty steep negative slope at a negative 2. So I would label this line, and I'll do it in a minute. And this one, it's at negative 1, and the slope is 4. 1, 2, 3, 4, 1. So I'm going to label this line negative 2x plus 5. And we can actually see the point of intersection already. And this line is 4x minus 1. You can see it's got a very steep positive slope. And the point of intersection is at 0.13. So we would have to conclude that this is a point of intersection. We can see it. So these two lines intersect at 1,3. A recommendation would be to go back and put both these points in and make certain. But with the good graphing programs we've got now, they do actually calculate the intersection points. And the next one would be y equals x minus 2 and y equals negative x plus 4. Let's go ahead, and I'm going to just put them here. Y equals x minus 2 and y equals negative x plus 4. I'm going to go ahead and just make another quick graph. I hope I've given myself enough room. I took a little bit more room than I probably needed on the first one. So I'm going to come down to a point -2, and the slope is up 1 over 1. I'm hoping I will find the point of intersection before I run out of graph. So let's label this x minus 2. Ideally, we would be doing these in different colors. And then we're going to go 1, 2, 3, 4, up 4. And the slope is -1. So this graph would get the line of -x plus 4. And the point of intersection is at 3, 1. So they intersect at 3, 1. Thank you very much.